Algebra 3, Chapter 3, Section 5, Variation. Okay, we're going to talk a minute about finding a line from a group of points, and this is something that you do a lot if you ever take a statistics class, and this is if you have a bunch of points or data you've collected and you want to find the line or an equation for a line that best fits as many of the points as possible or goes through the middle of the cluster of points as well as possible. Now, the process of doing this is called least squares regression, and the line itself can be called the least squares regression line. When you do this, and you do this on your calculator, you can do it by hand, but the calculator is much more precise. One of the things that it will give you when you do this is called a correlation coefficient, and it is a number between -1 and 1 that tells you how well the line fits the group of points. The closer to 1 or -1, the better the fit. So 1 or -1 would actually be a perfect fit. The plus or minus actually indicates the slope of that line. Now, how you do this is first you go to your calculator and you press Stat and then Edit. You're going to put the X values in list 1 and the Y values in list 2. Make sure they match up. After that, you're going to hit second and then mode quit, get out of there, and hit Stat Calc. When you hit the Stat button, you're going to go to the right to the Calc menu. And then once you do that, you're going to go down to menu option number 4, which says LINREG AX plus B, just like you see here. You're going to press Enter to find the equation that best fits the data. And what you're going to actually hit Enter the first time, it comes up on the home screen. The second time, it'll give you the equation. Now, before we actually do this, you may need to turn on some of the information in your calculator in order for it to give you this correlation coefficient. So what you want to do is hit second and then 0, which is the catalog, and you want to go down to where it says diagnostic on. So hit second 0, which is the catalog, go down until you find diagnostic on, hit Enter, and then on the home screen it'll say diagnostic on, hit Enter again, and then it should, it'll tell you that it's done and that the diagnostic is on. And once you've done that, you're ready to use the program or use the operation on your calculator. So for this example, you have the lengths in feet of the winning men's discus throws in the Olympics from 1920 to 2008. And you've got the year and you've got the length of the throw. You're going to sketch a scatter plot of the data. You're going to let Y be the length of the throw and T = 20 represent the year 1920. So in other words, instead of putting for your X values 1920, 1924, 1928, you're going to go 20, 24, 28, 32, etc. It just makes it a little bit easier. When you get to 2000, 2000 will be represented by the number 100, 2004 would be 104, and 2008 would be 108. So the years are going to be your X values and the lengths will be your Y. And you're going to go through this process. So you're going to go Stat. You're going to enter all of those years, 20, 24, 28 in list 1. You're going to enter all of the lengths in list 2. And we're going to use the regression feature on the calculator. So once you've done that, you're going to hit the Stat and then go to Calc and choose number 4. You'll hit Enter twice, write the equation down, and write down the correlation coefficient, which is represented by the small letter R. It's represented by the letter R. Pause the recording while you try this, and then resume the recording to check how you did. By the way, it said to draw a scatter plot. A scatter plot is simply all of the points put on the graph. And here we have the line drawn with it. You should have gotten something like Y = 1.02x plus 130.8. The R that came with it is 0.9685, which tells us the slope is positive, and it's actually a pretty good match. And if you look at it, the line is very close to most of the points. Up near the top, you have some more variation, but down near the start, they're very close. And again, usually in stats, in real world statistics, you're not going to have a perfect line. It's very rare and very unusual, and would probably cause you to question your data if it lined up perfectly. Now we're going to talk about direct variation. The phrase y varies directly as x, or y is directly proportional to x, means that you're going to write an equation of the form y equals kx, where k is a constant. K is called the constant of variation or the constant of proportionality. It cannot be 0. Now this is very similar to y equals mx plus b. You just don't have a b because the y-intercept is going to go through 0. So the slope, k is kind of like the slope, and your y-intercept is 0. And now we're going to try some direct proportion problems. What you're going to do, they've given you an x and a y value. You're going to write y equals kx. You will put in the x and the y value. You will solve for k, and then you will write the equation that relates it. So it'll be y equals the number you found times x, and that will be your final answer. Pause the recording, give these a try, and resume to see how you did. Okay, your first answer should be y equals 7x. Your second answer should be y equals 205x. And your third answer, y equals 2 pi x. Now, if you just found k and forgot to put it back in the equation, you need to do that. Make sure you follow the directions because it asked for the linear model. That means the equation of the line. Okay, now you're going to use the values of k and n to complete the table for the direct variation model y equals k x to the n. In other words, you're going to take each x given here in the table. K is going to be 1/2 and n is going to be 3, and you're just going to put them in the equation and get a y value. So for the first one, you're going to have 1/2 times 2 to the third. Pause the recording, fill out the table, and resume to check your answer. And you should have gotten 4, 32, 108, 256, and 500. Now, inverse variation is in the form of y equals k over x, or you could do x times y equals k. So an inverse proportion x is going to be in the denominator. K is the constant variation of proportion and cannot be 0. The graph of this function is not a line, but it's a curve similar to y equals 1 over x, which is the function. Now we're going to do a similar problem to what we did a couple minutes ago. This time we have k is 2 and n is 1. And this is an inverse variation, so we have y equals k over x to the n. Pause the recording, see if you can do these, and resume to check your answer. Okay, you should have gotten 1, 1/2, 1/3, 1/4, and 1/10. Determine whether the points represent a direct or inverse variation, then write the variation. Remember that if it's a direct variation, then every y can be gained by multiplying a certain number by x, and it'll be the same for the entire set. An easy way to check for inverse is if you can multiply the x and y and always get the same number. Pause the recording, give this a try, and resume to check your answer. Okay, it is an inverse variation. Every time you multiply the x times y, you get 5, which means 5 is our constant. So we have y equals 5 over x, or xy equals 5. Now, combined and joint variations. Combined variation mixes inverse and direct in the same problem. For example, y varies directly as x and inversely as z. Don't forget to include the k. So y varies directly as x is y equals kx. Inversely is z. When you see inverse, whatever follows it goes in the denominator. So y equals kx over z. A joint variation is always direct, but it's going to have more than one independent variable. For example, y varies jointly with x and z. So y equals k times x times z. So combined will be inverse and direct mixed. Joint will always be direct. It'll just have more than one independent variable. It can also be written as y is jointly proportional to x and z. All right, so try this problem. You're going to find a mathematical model for the verbal statement. In other words, write the proportions as equations. Pause the recording, try this out, and then resume to check your answer. F varies directly as g and inversely as r squared. So f varies directly as g is f equals kg, and then r squared is going to go in the denominator. The rate of growth R of a population is jointly proportional to the size S and the difference between S and L. So R is jointly proportional to S and S minus L. So R equals KS times S minus L. Don't forget to put the K in there. That's really one of the most common mistakes. These aren't really that difficult, but a lot of people forget about the K, and it's very important. Now you're going to do this in reverse. You're going to write a sentence using direct or inverse or joint or combined variation terminology. Pause the recording, give this a try, and resume to check your answer. Okay, here we have that the surface area of a sphere S varies directly as the square of the radius R. R is the only variable in there, 4 and pi are not, so S varies directly with R squared. Your answer could be slightly different, but should be similar. All right, now we're going to find the mathematical model that represents the statement, and we're going to find what the constant of proportionality is. Pause the recording, give this a try, and resume to check your answer. Okay, we have that A varies directly as R squared, and A is 9 pi when R is 3. So we have A equals K R squared. So 9 pi equals K times 3 squared, or 9 pi equals K times 9. So K is pi. So A equals pi R squared. For our second one, F is jointly proportional to R in the third power of S. So F equals K R S to the third. And so putting in the numbers, 4,158 equals K times 11 times 3 cubed. Solving for K, we get 14, so F equals 14 RS to the third. Now try a problem with Hooke's law. Hooke's law states that the distance a spring is stretched or compressed varies directly as the force on the spring. Pause the recording, give this a try, and resume to check your answer. All right, so the length of the spring equals K times the force. And if our length is 0.12 and our force is 220, then K must be 3 over 5,500. So L is 3 over 5,500 times F. And then putting in 0.16, we discover that we get for our force 293 1/3 newtons.